Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you what Kc expressions are and how you can use them to solve questions. I was doing an ICE table question in my previous video and I realized that these questions require Kc expressions, so I thought I would teach that too since it's pretty important. This is Unit D of Chemistry 30-1 in the Alberta curriculum. So let's get started. Okay guys, so first of all, what is a Kc expression? So I wanted to start the video by explaining some rules and basic things you need to know about Kc. So Kc is basically the ratio of the product concentration over the reactant concentration. And when you're doing these calculations, you need to make sure that the concentration is at equilibrium, okay? And when you're making your Kc expression, you can include the gases and aqueous forms, but whenever you have an equation where there's solids and liquids, you cannot include them in your Kc expression. And when you find the value of your Kc, it's just going to be a value. It's not going to have a unit. Like concentration has the unit moles per liters, Kc doesn't have a unit, so it's just going to be a number. Okay, so let's move on to some easy examples. And guys, one more thing I want to mention is that this is the equilibrium law. And this basically is showing that what would happen if the equation had a coefficient. So if an equation has a coefficient, then in the Kc expression, that is going to turn into a power. So let's say, for example, A had the coefficient of 3. That means in the Kc expression, we would put the power of A as 3. Okay? This is like really simple, so I'm not going to explain it much, but I just wanted to mention it before I start on the examples. Okay guys, so let's say we have this equation given to us. What would be the Kc expression for this equation? I want you guys to pause the video and comment down below right now what the Kc expression would be. Okay, so I'm going to explain it now. Kc, as I said before, is the ratio of the products to the reactants. So obviously our NO2 would be in the numerator and our reactants would be in the denominator. Check the states first. Is there any liquids or solids? No, there isn't. They're all gases. So we can include every single one of these into our Kc expression. Next thing you want to do is make note of the coefficients. These coefficients are going to turn into powers in our Kc expression. Okay, so I'm going to go ahead and write the Kc expression now. Okay guys, here I wrote the Kc expression. I don't really know how to explain this because it's really simple. You just have to follow the formula. The products in the numerator, the reactants in the denominator, make sure the coefficients turn into powers. And yeah, that's all you need to know for Kc expressions. Okay, I'm going to move on to something a little bit different. Okay guys, so here is an actual word problem. This question gave us the equation and now it's asking us what is the value of Kc. So it told us that 0.249 moles per liters of N2, 3.21 times 10 to the power of negative 2 moles per liters of H2, and 6.24 times 10 to the power of negative 4 moles per liters of NH3 are all combined in a 1 liter vessel at 375 degrees Celsius. So it gave us the concentration of each of these at equilibrium, and it's asking us to find the Kc value. It gave us some extra information to confuse us, but just know that you don't need to do anything if you're given something like this. It gave us the volume and the temperature. You don't need that because you already have the concentrations given to you. So as I said, now you're going to make your Kc expression and plug in each of the values they gave us and solve for Kc. So we have our coefficients here. And they didn't give us any states, so just assume that these are all gases and you can include them in your Kc expression. So keep in mind that these coefficients are going to turn into powers. So I'm going to go ahead and write our Kc expression and then we'll find what the value of Kc is. Okay guys, so here is our Kc expression. The concentration of NH3 at equilibrium is this value. I put that into brackets and squared it because the coefficient is 3. And the concentration of H2 at equilibrium is this value, and we have to cube it because there's a coefficient of 3. And the concentration of N2 is just this, and we're not going to put it to any power because the coefficient is just 1. Now you can just directly plug this into a calculator and you'll get your Kc value. So I'm going to go ahead and do that. Okay guys, so I plugged it into my calculator and I got that Kc equals 0.047. What I did is I rounded it up. I don't think you guys need to do that, but I like to round up. And I got that Kc is 0.05. And remember, Kc has no units, so you're just going to leave your answer as a value. Okay, that's what most Kc questions are going to look like. Either you make the equation for it and just leave it without any values, or it's going to ask you to find Kc, and sometimes it could even ask you to find the concentration of a reactant or a product. I want to keep this video short because it's a pretty easy topic, so I'm going to stop here for today. Okay guys, so that's all for today's video. I kept it short because Kc is a very simple topic, and after watching this video, I think you guys should rewatch my ice table video because that is basically built upon the concept of Kc. So yeah, that's all for today guys. See you guys next time. Bye.